Morning students. We have been discussing exercise 7.1 in the last two videos and most of the questions were solved for you on the board. Right? In continuation to that, one question is left out, that is question number 8 from page 120 of exercise 7.1. Why I have kept this question separate last video? The only reason because this question involves knowledge of your previous chapter as well, lines and angles. There are certain properties of lines and angles that are going to be used over here. That is why this question number 8 becomes very important for this chapter. Right? It has the emphasis of all the previous chapters. Clear? If you remember, I had made you fold one page number 100. So keep that page open for you for this chapter. We will be using certain properties from that chapter. Right? What does it say over here? In a right triangle ABC, I am drawing the figure, reading the question. In a right triangle ABC, right angled at C, this is a right angle triangle. Right angled at C, this is A and this is B. This is right angle and this is the right angle triangle. M is the midpoint of hypotenuse AB. M is the midpoint of the hypotenuse AB. So that means this AM is equals to PM. Then he says C is joined to M. C is joined to M and produced to a point D. C is joined to M and produced to a point D, such that DM is equals to CM. DM is equals to CM. Point D is joined to B. Point D is joined to B. Right? Show that. He wants us to prove certain things. So what are the things given to us? First of all, given to us right triangle ABC in which angle C is equals to 90 degree and M is the midpoint. M is the midpoint of AB and CM is equals to DM. What we have to prove? We have to prove certain things. First, triangle AMC congruent to triangle BMD. Second, angle DBC is a right angle. Angle DBC is a right angle. Third, triangle DBC congruent to ACB. Triangle DBC congruent to triangle ACB. Fourth, CM is equals to half of AB. CM is equals to half of AB. These are the things he wants us to prove. Construction not required. Everything is constructed for us. We have read the question and we have drawn the figure after reading the question and we have marked the things which are equal. He was saying that M was the midpoint of hypotenuse AB. So this AM is equals to BM. Can you see two dots? Two crosses. Then he said CM was equals to DM. So CM was produced to a point D such that CM was equals to DM. Two dots. Right? Now he tells us to prove these four things. Triangle AMC congruent to BMD. Where is AMC? AMC, this triangle, congruent to BMD, this triangle. Yes? Let us see. Proof. In triangle AMC and triangle BMD, let us see what are the things we find equal. They are not equal. You have to observe AMC and BMD. Can you see AM is equals to BM and CM is equals to DM? These two sides are given to us. AM is equals to BM and CM is equals to DM. Reason, M is the midpoint given to us. M is the midpoint. And this is also given to us that CM is equals to DM. Two sides are equal. And when two lines intersect each other, the vertically opposite angles formed are equal. We have proved the theorem over there. Remember? So that means angle AMC is equal to angle BMD, vertically opposite angles. So therefore, triangle AMC is congruent to triangle BMD. By what congruency? Check. AM equals to BM, CM equals to BM, two sides are equal and the angle between two sides is equal. So what congruency? SAS. Isn't it? Yes or no? This is how we prove it congruent. Now, once we prove them congruent, what are the other things we can see? We can see that two sides of this triangle are respectively equal. Will the third automatically become equal? Definitely, sir. Reason CPCP. Will this ACP equals to BD? Yes. AC is equals to BD. Once we prove them, then it is equal. Right? Then, is this angle corresponding to this one? Not to angle D. It is not corresponding to angle D. Angle A is corresponding to this angle. Sir, why? Observe carefully. Just check. This angle A is between the side AM and AC. It is the included angle of AM and AC. AM is equal to what? BM and AC is equal to what? BD. So which is the included angle? Not angle D. Included angle is this one. I call it angle number 1, angle number 2. Angle number 1 is equals to angle number 2. Reason CPCT. And same way, this angle is equal to only this much. 1, 2, 3 strokes. Angle number 3 is equals to angle number 4. Angle number 3 is equals to angle number 4. And reason for all of them is CPCT. Corresponding parts of congruent triangles. Since we have proved these two triangles congruent, their corresponding parts are also equal. Clear? Right? So, now we come down to the next part. Triangle DBC is right angle. Where is DBC? DBC. So, how? How? Yes, there is no option. So, how it is equal? 90? How it is 90? So, now here we use the property of alternate interior angles. Page number 100. Please observe that page. Theorem number 6.2 and 6.3. What does it say? Can you see this angle 1 and 2 are alternate angle? 1 is this is a transversal AB intersecting these two lines. So 6.3 says if two alternate interior angles are equal, then the lines are parallel. Because angle 1 is equals to angle 2, that is alternate interior angles are equal. Therefore, AB is a transversal intersecting parallel lines AC and BD. That is, AC is parallel to BD. This AC is parallel to BD. By which theorem? You can refer to theorem number 6.3 of page number 100 of your textbook. If a pair of alternate interior angles are equal, then the lines are parallel to each other. Now, once these two lines are parallel, you can see another transversal BC. Is this parallel line also intersected by this transversal BC? So, again we come down to theorem number 6.5 of your textbook. Page number 100, I said it is very, very important. Page number 100, it says, if a transversal intersects two parallel lines, then the sum of interior angles on the same side of a transversal is 90. Now, BC is also a transversal also a transversal for lines AD and BC. So by we know sum of interior angles on the same side of transversal is 180 degree. That is theorem number 6.4. So we can see the interior angles. Which are the angle C and angle B? So therefore angle ACB plus angle DBC is equals to 180. Can you see? This is a transversal. These two are parallel lines. So angle C and angle B are supplementary angles. Angle ACB is already given to us. How much is that? 90 degree. Angle ACB is already 90 degree. Angle DBC we have to find. Plus 90 comes over here, minus 90. So angle DBC is equals to 180 minus 90. So therefore angle DBC is equals to 90 degree. Second part proved. First and second. This was the important part of the question. If we cannot do this, then we won't be able to solve the rest of the part. Now we have proved that this complete angle is 90. Clear? Now it says prove triangle DBC. Where is DBC? DBC congruent to ACP. In triangle DBC and triangle ACP, check. Is one angle 90-90? We have just now proved over here. Angle DBC is equals to angle ACB is equals to 90. Proved above. Right now we have proved. Right? Another thing that is equal. Can you see? This side AC is equals to DB. We have proved AC equals to BD. BD is equals to AC. Proved above. Here it is. Yes. And thirdly, is this side common to both the figures? Triangle ACB and triangle DBC. Is this BC common? BC only observation. BC is equals to BC. That is common. So therefore, triangle DBC is congruent to triangle ACB by what congruency? SAS. Which one? SAS. Two sides and the included angle. And if these two triangles are congruent, is their hypotenuse also equal? DCB and AB. 90 degree opposite is the hypotenuse CD. Opposite to 90 is the hypotenuse AB. So therefore, CD is also equals to AB. Reason CPCP. So why did you use it? Because to prove the fourth part, we require it. Clear? Very important question. Now see, what do we want? CM. Not the CM, sir. This is CM. Is this CM a part of CD? So we return over here. Because CD is equals to AB. Now observe the CD. This CD is made of two parts, CM and DM. So this CD is broken as CM plus DM is equals to AB. But is DM and CM equal? Yes sir, DM and CM are equal. Because CM is equals to DM. So therefore CM plus CM is equals to AB. This DM is broken in the form of CM. CM plus CM, twice of CM is equals to AB. 2 is in multiplication, goes into division. So therefore CM is equals to half of AB. Correct? You can see this question is very important. That is why I have kept it all together separate. We did not do it with the exercise. This question uses the properties of the previous chapter. If we cannot use these properties, we won't be able understand the question. That is why I told you to keep your page 100, number 100 open. We have used two properties of page number 100. Clear? Please go through it, practice it. This exercise is very, very important and it will help you. Thank you everyone.